Hi, everyone. Welcome to the International Methods Colloquium. My name is Dr. Justin Essery. I'm an assistant professor of political science at Rice University. The International Methods Colloquium is a periodic online interactive seminar discussion on the application of quantitative statistical methods to the social sciences, sponsored by Rice University and the National Science Foundation. And this week, I'm pleased to introduce our speaker, Kosuke Imai, a professor at Princeton University. He's going to be giving a talk entitled Survey Methodologies for Sensitive Questions. Kosuke's talk is going to last about 30 to 40 minutes, after which he will be available to take questions on the air. And I'll just show you, there's a call-in line. No, apparently the number's not showing up. That's weird. Let's try that again. There we go. There's a call-in line you could call, 855-1-855-667-8287. That's 1-855-NO-STATS, in case you use the little words on your phone. You can also email questions to methods.colloquium@gmail.com. I recommend, in terms of calling, you wait till the end of the program to call in so you don't have to sit online for 20 minutes or something. At the end of the program, we'll give another sort of prompt to call in and ask questions. A copy of the slideshow is available. I'm showing the link to that right here on my screen. So if you'd like to take a look and look back through slides, you can do so. But of course, the slides will be shown on screen as well. And is there anything else? No, I think that's it. Well, with no further ado, I'd like to welcome Kosuke to the first edition of the IMC. Kosuke, welcome.
All right. Well, thank you very much, Justin, for invitation and introduction. So I'm very excited about giving the talk. Never done this before, so we'll see how it goes. Today, I'm going to talk about the survey methodology for sensitive questions that I've been working over the last few years. And I want to acknowledge my collaborators who is listed on the bottom of the slides, Graham Breer, Jason Lyle, and Bryn Rosenfeld, and Jacob Shapiro. Okay, so let me start the talk, and hopefully after the presentation, we'll get some interesting conversation going. All right, so the motivation for this project was really coming about as a challenge to measuring sensitive attitude and behaviors. So survey methodology is still a dominant mode of data collection in political science and other social sciences, but we know that when we try to measure sensitive attitude and behaviors, we have the issues of social desirability bias, so that people were compelled to answer in a certain way, even though that's not actually the truthful response. So, for example, famous example would be turnout, where even if you didn't vote, you're more likely to vote. You're more likely to answer that you voted if that's a social desirable outcome. Also, there's a non-response bias. So when you ask very sensitive questions, people don't feel comfortable giving the answer, so they tend to skip that question. Right. So over the last few years, I mean, these methodologies have been around for a while, but in the political science in particular, indirect questioning methods have become quite popular. So the three methods that I'm going to talk about is the risk experiment, endorsement experiment, and randomized response. And I'll talk each of these methodologies in detail throughout the presentation. What I've been working on over the last few years is to develop statistical methods. So it turns out that some of these methods have been around in the literature for a long time. The statistical methods for analyzing the data from these experiments survey experiments have been pretty minimal. So we have worked to develop multivariate regression for each survey technique so that we can estimate not only the proportion of people who are saying yes or no to sensitive questions, but we can predict who are more likely to answer yes or no to these questions. We might also want to use responses from these indirect questioning methods as predictors in the outcome regression. And as it turns out, it's not straightforward because you actually don't observe directly what the answers are. So these are the statistical methods I've been working on, along with some other techniques such as statistical tests for detecting the violation of assumptions. Now, what I want to organize today's talk is around the empirical validation, right? So any of these methods or any methodologies, when you use it, you want to make sure these methods are working. And it is difficult to validate these methodologies precisely because sensitive attitudes and behaviors don't really have, it's hard to obtain a ground truth. But I want to organize these talks through sort of my empirical attempts to validate these methodologies. So first one is to try to validation against the ground truth, not at the individual level, but at the aggregate level. So if you have aggregate level truth, can you do a survey and then come up with the estimates that are close when it's aggregated, when it's close to the true values? And the second example we're gonna look at is in the absence of the truth, can we try some of these multiple methodologies and then come up with a similar results? Okay, the third one, which I'm not going to talk about today, is to think about how can we use these survey responses to predict actual behavior. And that might be another indication that you're measuring something that's very important. If it doesn't really predict the behavior, then your measurement may not be very good. Okay, so that's basically the overview of the talk. So I'm going to start with the one validation study that we did in a couple of years ago, the Mississippi validation study. So here we were looking at the anti-abortion referendum that was voted in Mississippi, and estimating what's the vote distribution on this referendum using a variety of survey mode. So first one was a direct question, second one a list experiment, and endorsement experiment, anonymous response. So the idea here is to validate these estimates coming from the survey methodologies against official election outcome that's available at aggregate level. So we started with getting a sample of the voters, the people who actually voted from the voter file, and then we're going to we run this survey, and we're going to estimate the proportion of people who voted yes or no on this referendum, and we're going to compare these estimates against the actual county level official election outcome. Okay. So what was interesting about this referendum is that it was basically trying to say that the life begins at the conception, so then the abortion is going to be legal, and incorporate that in the state constitution. And there was an opinion poll that was conducted 24 hours right before the election, and it predicted 44% of no votes. So they thought this anti-abortion referendum would pass easily. But it turns out the actual election, the day later, the amendment was actually defeated by the opposite of election results. So basically, the poll got completely wrong. So we wanted to know whether this was in part attributed to the sensitivity of the subject matter. So what we're going to show you is that we found that direct question is quite biased. So this is the survey we did after the election. So the post-election survey asked whether you voted. And you'll see that our estimate actually is very close to the pre-election poll result that was severely biased. Significant underestimation. And then it will show you that the indirect methods, these three indirect methods, are actually come much closer to the official election results. And in particular, endorsement and randomized response yielded least bias. Okay, so how did the survey questions were worded here? So the direct question was a simple one. So did you vote yes or no on the person food initiative? That's the controversial anti-abortion referendum, which appeared on November 20th of the Mississippi general election. Okay. The risk experiment, this is the one that you add one sensitive item. So you split the sample into two groups, you add one sensitive item, and then look at the difference. Okay, so the question goes, here is a list of 4 things that some people have done and some people have not. Please listen to them, and then this was a phone survey. Then tell me how many of them you have done in the past 2 years. Do not tell me which you have done and you have not done. Okay, so just tell me how many. So you don't need to answer each one of them. You just need to give aggregate count. So you have two groups. One, a control group, only got the first 4 questions that are not sensitive. And then the treatment group got this, in addition to these 4 questions, you got this 5th question. So that's the risk experiment. So what about the endorsement experiment? So endorsement experiment goes like this. So we would like to get your overall opinion of some people in the news. As I read each name, please say if you have a very favorable or somewhat unfavorable or very unfavorable opinion of each person. So typical 5-scale question. And in one group, so again here the sample was split into 2 groups. One is control and the other one is treatment. So one group just listed the name of the governor. Do you support this governor? And the other one basically noted the fact that the governor campaigned in favor of this initiative. So the idea here is that there is a psychological literature that shows that if you pair something with other thing that you really like, your opinion about the first thing becomes much more favorable. So the idea here is that if the governor was paired with the fact that he was supportive of person food initiative, then if you actually support this initiative, you should have a more favorable opinion of the governor than if that fact was not noted or else equal. So so that's basically the idea of endorsement experiment. So this one is a little bit more indirect way of measuring a support for initiative. And finally, the randomized response. So this one is perhaps most complicated because you need to ask survey respondents to do something. So here you see that to answer this question, you need a coin. Once you have found one, please toss the coin 2 times. We asked 2 times because the first one was a practice. There was a practice question I'm not showing here. And note the results of those tosses, one after the other on the sheet of paper. Right? So write down what you got, head or tail. Do not reveal to me whether your coin lands on heads or tails. So don't tell me. You just flip a coin. You write down the outcome of the coin flips, but you don't tell me what you got. Okay? And then the question goes as follows. Now, please answer yes if either your second coin toss came up heads or you voted yes on the Person Food Initiative, which appeared on the Mississippi general election. Okay, so if someone says yes, I don't know whether you said yes because you voted for the initiative or you just got a coin toss turned out to be head. Okay, so that way you add some random noise to protect the anonymity of the respondent's answer to the sensitive question. All right. So basically, these are the 3 methods that we tried, and in the last few years, I've developed a few ways to analyze these sensitive survey experiments. So I'm going to go through quickly how we analyze each method. Now, I think, given a time constraint, the details you can look at the papers, but I'll convey the intuition. Okay, so suppose you have yi observed response. This is a list experiment, so you're getting a count, and you have a bunch of covariates x. You think about zi star as a latent response to a sensitive item. So whether this person is actually saying yes or no to the sensitive item, you don't observe that. You also have yi star, which is also latent response to the control item. So this is the number of yeses for the control items. You observe this for the control group, but you don't observe this for the not necessarily observe this for the treatment group. And you can see the observed response is a function of the yi star and ti and zi star. So if the ti is 1, that is the treatment is 1, if you're in the treatment group, then you get the sum of yi star and zi star. Okay? So there are 2 important assumptions. So there's no design effect. That is, your response to the control items don't change by the addition of the sensitive item. Okay? So what that means is that adding the 5th item shouldn't change your answer to the first 4. Okay? So this might happen if people are evaluating things relatively to each other. The second one is you're not lying about the sensitive item. Now, if the question is very sensitive, you may actually some respondents may lie about that. Okay, so you can see there are a total of 2 times j plus 1. J is the number of control group types. That is, you can characterize each respondent by the latent response to the sensitive item. So you might be someone who said yes to the sensitive item or no to the sensitive item. So it's either 0 or 1. And then you might be the person who says yes to all the control items, in which case why I started before, or maybe just 3 or 2. So you can enumerate all this group, and you see that in the treatment group that some cells that we observe, right? If you say 1, for example, in the treatment group, you're either saying yes to the sensitive item and no to all the control items, or you're saying yes to the one with the control item or no to the sensitive item. Okay, so you can see like in these 3 cells, it's a mixture of 2 types. You don't know what the proportion is. In the control group, it's also a mixture, because if you say 1, you know that you said yes to the one of the control items, but you don't know whether this person actually says yes to the sensitive item, 1 or 0. So you have a mixture. Okay. But luckily, you can identify the proportion of each types by looking at these cells. So, for example, if I subtract the proportion of people who said either 0 or 1 in the treatment group from the proportion of people who said either 0 or 1 in the control group, you're basically left with the proportion of people who are saying yes to the one of the control group item and yes to the sensitive item. The reason why is that this group and this group is randomly divided, so each of these proportions actually are equal in expectation. So all of these things cancel to each other, and you're left with that. So by doing this, you can basically come up with a proportion of every possible type of respondents, and you can, for example, you can test whether the assumption is right by looking at whether these proportions are actually become negative value, because it should, proportion should be positive. So if you see something negative, you know that there's something wrong going on. Okay. So by virtue of this, you can actually run build the model logistic regression, modeling the sensitive behavior, and also model the responses for the control items, and you can do this all in the likelihood framework. Okay, so that's basically how the risk experiment worked, how to analyze the risk experiment work. And for the sake of time, I'm going to skip the statistical methods for the other 2 methodologies, but it has a very similar flavor that you're going to model the latent response to a sensitive item using, say, logistic or probability regression, and build the entire model for under the likelihood or Bayesian framework. Okay, so let me skip this and then go to the results, which might be more interesting for the sake of discussion. Okay, so here you see that on the x-axis you see the county names, and you see the proportion of no votes on the personhood, and the actual votes are given by the red dots. And direct question, you see that it's severely underestimated. So a lot of people seems to be saying, yeah, I actually voted for the initiative even though they didn't. Okay, so this is very similar result to the pre-election poll. Now, if you look at the indirect question techniques, you see that they get closer to the truth. Okay, even though it doesn't go there completely. And there's 3 types of results: unweighted, weighted, and regression adjusted. So there's non-response. So that's another complication of surveys, that you have non-response. People, especially with a phone survey, you can't reach people. So there are a lot of, you have to adjust for the non-response. And how to adjust that is another issue. So here we are doing standard adjustment, but that so that any bias can come from either from the non-response bias or the social disability bias. And you can see that the risk experiment is a little bit better. Endorsement experiment is a little bit noisier, but slightly maybe better than risk experiment. And the randomized response seems to come closest to the actual vote share. You can also look at this by country, by county by county. So point estimates you can get. So I have a method that I developed where you can get the point estimate using random effects model. And then you can see there's 3 types of results again, but let's just focus on the first type because it's all similar. You can see direct question is uniformly biased. Risk experiment get better, but it seems that it doesn't really pick up. It doesn't have enough statistical power to pick up the actual heterogeneity across counties. It's all giving the similar results. But it's certainly biased, and root mean square error is smaller than a direct question. Now, endorsement experiment is noisy, but it seems to get it right. Like the correlation is much higher, and randomized response seems to do even better. The scatter around the 45-degree line. So this is actual an estimate. So if you're right on, you're going to be on this 45 degrees line. Okay. So now that I showed you a validation study, the last thing I'm going to show you is another application where if the truth isn't available, how would you actually be confident that you're measuring what you are trying to measure using these techniques? So here the application is, how do we measure civilian attitude in a conflict setting? And it turns out this is a very important problem because of hearts and minds strategy in Afghanistan. And it turns out the USAID and ISAF, that's the international forces, they have lots of surveys going on, but they mostly rely on direct questions to measure this civilian attitude in a conflict setting. So the questions like, who do you believe can solve your problems? And apparently, if you say ISAF, international forces, you're in supportive of international forces. Well, you could they've also asked that over the past 6 months, do you think the Taliban have grown stronger, grown weaker, or remained the same? Okay. Why asking the direct question is such a bad idea in Afghanistan? Well, there are a lot of issues. Okay, so one issue is the threats to enumerators and respondents. It's actually very dangerous to answer these questions because the interviews are public. Okay, interviews are publicly conducted. You're not actually allowed to talk to someone in private. So when you go to village, when you send the enumerator to the village for the survey, they have to ask questions in the public area as opposed to like in a room of a house. Okay, and so there's a lot of issues about non-response or social desirability bias. In fact, some of these surveys I listed have like non-response of 50%. Refusal rate. Okay, so here's a picture of how the interviews are conducted. So here's the enumerator, here is the respondent, and there are these 2 scary-looking people observing what's being asked, and there are some kids running around. Okay, so it's interviews are conducted in the public, so there's a large possibility of social desirability bias and non-response bias. Okay, where did we do the survey? These black dots are the villages that we fielded the survey. It was randomly selected using a multi-stage cluster random sampling. The red dots are basically the violent events. So it's either the fight between the Taliban and then the Afghan forces or international forces. So you can see that in the area Helmand is a very violent area, and we did a survey in that in the heartland of basically insurgency. And the red area is a so-called Taliban-controlled district. So these are very challenging areas to do a survey. So we did the endorsement experiment here. So here's a script for the control group. A recent proposal calls for the sweeping reform of the Afghan prison system, including the construction of new prison in every district to help alleviate overcrowding in existing facilities. So this is like prison reform. Do you agree? Disagree, indifferent. Now in the treatment group, all we did was to add this proposal by ISAF. Okay, so we are trying to measure the support for the ISAF, and the control group was just said proposal, and then treatment group was just one word different by ISAF. Okay, so the idea here is that if you are in supportive of ISAF, then you should give a higher support for this prison reform if the proposal was said to be endorsed by the by ISAF. Okay, So that's a very subtle intervention, but that's the idea of endorsement experiment. So you're asking the support about the policy as opposed to the actor, which in this case is a very sensitive actor. Okay, here's a look at the actual raw data. And let's focus on the overall results on the top. And so there are 4 questions, so the prison reform is the second one. And you can already see there's some differences, right? So the strongly agree is a dark one, and then you get lighter as you become more disagreeing with the policy. And you can see when the Taliban endorses it, there are a lot more people than ISAF who say, I like this proposal. Okay, so, and it's most obvious in Harman, which is the most violent place. Okay, so you can see there's a huge gap, whether you mention Taliban or ISAF. Okay. And what's another thing interesting is that non-response rate here is very small. So this is actually refusal, and I think it's less than 5% here. But in the violent area, it's a little bit higher. And so you can also see how the sensitivity and non-response correspond with each other. Okay. Now, we also did the risk experiment. So the idea here is to, even though we don't know the ground truth for what the proportion of people who support ISAF, we can pair 2 indirect questioning methods. They're very different, and see if we can get the same answer. Okay. So the risk experiment basically has the same nature as the one I introduced before. You basically list the actors in this case and ask how many of these actors you support. So in the treatment group, you add the sensitive actor, which is the ISAF. Right? So again, the idea here is to compare these 2 results. And if these 2 results are measuring the same thing, they should be correlated, even though their question format is amazingly different. Okay? So let's compare these 2 experiments. So this is sort of motivation here, the multiple measurement strategy as a way to validate the results in the absence of the truth. So what we want to ask is, what is the probability of supporting ISAF, or what is the proportion of people who support ISAF? Okay. So risk experiment, you can get probability of saying yes to the sensitive item. From an endorsement experiment, although I skipped the detail of the model, you can also get the probability of endorsement having the positive effect on the support for policy. And we're going to interpret that as a support for ISAF. So we want to compare these 2 probabilities, and if we're measuring the same thing, they should be very similar. Okay? And with the methods that I've developed with my collaborators, these 2 probabilities can be estimated using the method. Okay? And so you can either separately estimate these probabilities and compare, or you can even build the joint model to combine these experiments by treating these 2 probabilities as the identical probabilities. So here, let me sort of, for the sake of time, let me skip the details of the model, and then we can come back to in the Q&A if anyone is interested. But the idea is, is elaborated in the previous slide, where basically in the risk experiment, we're going to obtain the probability of saying yes to a sensitive item. From the endorsement experiment, we're going to obtain the probability of endorsement having the positive effect on the support for policy. And then we're going to compare them or combine them together. Okay. All right. So before we get to the multivariate analysis, it's always important to look at the raw data. Okay, so here is a raw data graph showing already how these 2 measurements, even though they're very different, actually giving you very similar results. On the left hand, it says control group. We are simply comparing the endorsement experiment, this response to the endorsement experiment to response to the risk experiment. Okay, so the circle, the area of the circle is proportional to the number of respondents who are in the in that category. So if you answer 4, which is the more favorable, and then you said yes to risk experiment, then you'll be in this category. So this is just a scatter plot. And what you observe is, although there's a little bit of outliers, so the line, the ROS line is going downwards, the correlation is fairly weak. So the Pearson correlation is 0.16, and then this is the rank correlation. Correlation is 0.1. Okay, I think it's Spearman correlation is 0.1. So the correlation is very weak. Now look at the treatment group. So the only difference here is the endorsement experiment has the endorsement by ISAF, and the risk experiment has additional items. So it's the response can go from 0 to 4 instead of 0 to 3 in the control group. And then now the correlation is much higher. So in fact, the Pearson correlation is a 0.5. So going from this, because these are randomly selected, randomly divided subgroups, going from this control group to just adding one question and in the risk one sensitive item to the risk experiment and endorsement by the sensitive actor in the endorsement experiment raises the correlation from 0.16 to 0.52, like more than 3 times. So you already see, right, people moving. If you are favorable, you're moving this direction in the endorsement experiment. If people are not favorable by ISAF, move in the other direction. The risk experiment, if you're favorable by ISAF, you go and move in that direction. So that intervention is actually giving a positive correlation. And you also observe this across questions. So remember, the endorsement experiment have 4 questions. So there are different questions: direct direction, prison reform, and so on. And you can see the correlation in the treatment group is higher. Except the prison reform, the correlation is lower. But the all 3 other ones have very high correlation. Whereas the control group the correlation remains to be very, very small. And what I think is even more interesting is that the highest correlation by question, if you look at the question by question, it's 0.5, whereas the overall correlation was 0.52, right? So combining all 4 questions, you get more power. You actually get the higher correlation, higher than any individual question. Even though there's one question that's not very informative, this gets weighted down. So by combining multiple questions in the endorsement experiment, you get much higher correlation with the risk experiment under the treatment condition. So all this seems to suggest, even descriptively, that risk experiment and endorsement experiments are actually giving the very similar results. Now, if you look at the multivariate regression technique, the results are even more stark. Okay. So here, we simply estimate the overall proportion of ISAF supporters. So you see that ISAF is not very popular, recording about like 17–18% of African population that we surveyed supporting the ISAF. So you can see, but the risk experiment, endorsement experiment, is essentially giving the identical proportion. Estimate, this is separately estimated figure. So the proportion of people who are saying yes to the sensitive item in the risk experiment and the proportion of people who are having the positive effect of endorsement by ISAF is essentially identical. Okay, so here's the difference. It's basically point estimate is very close to 0 with some confidence interval. And you can combine these 2 estimates and provide a single estimate, which gives shorter confidence interval than either of the 2. Okay, so in this case, we've found that these 2 experiments give very similar results. So just to conclude, what we have shown is that direct question is severely biased. So in 2 examples that I introduced, in the Mississippi example, the direct question was basically calling the direction wrong. In the Afghan experiment, you wouldn't even be able to ask directly. In fact, we wanted to compare with a direct question, but the IRB said, no, you can't do that for the safety of enumerators and respondents. So we found that all indirect methods seems to reduce bias either to social desirability or non-response. In the Mississippi design experiment, we found that the endorsement and randomized response seems to have smaller bias than this experiment. Yeah. However, the risk experiment is popular because it's very easy to implement. Endorsement is harder because you have to come up with what are the good things to include for the endorsement. Randomized response is even harder because you have to tell, you need to have respondents to do something on their own. In the African example, I've shown you the use of multiple measurement strategies when the truth is not available. And that's a valuable strategy for anyone who is trying to study sensitive questions. You don't want to rely on single measure. You want to try 2 or 3 measures to make sure that what you're measuring is the thing you're trying to measure. So there are a lot of, I think, work to be done in for the future research for anyone who is interested. How to balance bias, precision, and cost, or anyone who is implementing these survey methods recognizes that even though you might be able to reduce the bias, we have, the indirect methods have much wider, much less precise. They're much less precise than the direct question because you don't observe the response directly. And as a result, it's more costly in order to get the statistical power you like. So you have to think about how to optimize across all these different parameters, dimensions. And we should also build more studies that use aggregate level truth, and you can incorporate the aggregate level truth to improve individual level estimates. So in some cases, like in the Mississippi case, we don't have individual level estimates, but we do have aggregate level truth. So it's possible to incorporate that information in order to improve individual level estimates. And this is something I'm working on currently. For anyone who end up using these survey experiments, we have open source software. So it's all in R, and you can use these packages to replicate any of the analysis that I've conducted and more. And so if you have any questions, you should feel free to contact us. And the last slide just gives you a set of papers that I've been writing on these topics. So if you want to know more details about each of the part of the talk, feel free to take a look at these papers. And also there's some applications that might be of interest to people who are interested in substantive issues. So thank you very much, and I look forward to the conversation.
Okay, Kosuke, thanks very much for your presentation. At this point, Kosuke is available to take questions for about 20 minutes from the audience. I want to repeat the ways that you can contact us. First, you can call 1-855-667-8287. That's 1-855-NO-STATS. That's a toll-free call in the United States. Outside the United States, I have no idea. Probably not. And you can also email questions to us at methods.colloquium@gmail.com. And if you'd like to ask Kosuke a question, please contact us through one of those methods. I'm going to go ahead and get started with a couple of questions I had during your talk, Kosuke.
Okay.
So it seems like this is sort of broadly similar to an idea of having multiple noisy measurements of some underlying thing, right? So
that's right. Yeah.
There's two sources of signal that are informing what you're measuring.
Right.
And I want to extract one of those things out of it. And so just like any other measurement problem, the more hopefully related measures of the same thing I have, where the noise components are unrelated, but the systematic components are related, I can then use some sort of methodology to extract the common component.
Right.
So that's what I was sort of thinking about. And then so the question I had was, we know seemingly, I think, we know a lot about how to do that, right? There are lots of books about, principal components analysis and stuff like that. So to what extent are the techniques that you've laid out here similar to or different from those techniques? And if they're different, why aren't these other techniques something we might be able to use?
Right. Well, that's interesting. Yeah. So one thing I'm going to note about, this is very actually interesting question because I never thought about the relationship across measurements. So if you think about, let me go back to the wrist experiment here, for example. So the standard sort of recommendation for the wrist experiment, which actually Adam Green pointed out first, is to pick the control items that are basically, have a negative correlation. So you don't want everyone to be saying yes to all the control items, or people saying no to all the control items. Because if you actually say yes to everything, then you know that you're supporting ISAF. If you actually say zero, then you know that you're not supporting ISAF.
Right.
So by having the high correlation across control items, which is the thing that you're trying to add to provide anonymity. So there's the implication for both statistical implication, which is, yes, you get the high statistical precision because you know exactly what people are answering, and yet you have low, privacy protection. So the privacy protection and the statistical efficiency is basically the explicit trade-off. Now, coming back to your question of across measurement strategies, that's a very interesting one, because ideally, like you said, you want the noise to be uncorrelated, because if the noise are correlated, you think of that as a part of the measure, common measure, even though when it's not. So I think the logic that you just read out is exactly right, but I haven't really figured out how to design the list and say endorsement such that people I think thought hard about how to design each one separately, optimally, but they haven't thought about if they're going to combine how each of these should be should be designed to be optimized, together. Mm-hmm. And it may be the answer to that question might not be the same as just do your best in each one. So that's certainly, that's something that we need to think about. Now, for the endorsement experiment, you already also might have noticed that we have multiple questions. So we had like 4 different questions here. And so here it's like item response theory, like you referred to. We don't want to rely on one measurement, so we don't want the loading to be high on only one question. We sort of want to cross, similar loading but we at the same time we want to be on the same dimension. So there's same issues that would come up with in the item response or any other sort of survey, combining survey question type of issues.
Well, I have another question. And so, one of the things I was thinking about was something I kind of want to know about certain things. Like you mentioned at the beginning, there was an abortion example. Mm-hmm. I kind of want to know, as a social scientist, the extent to which people's opinions about that are informed by social desirability. So the extent to which they secretly think one thing and they say something else because they're worried about their neighbors or whatever. Right. Do you think there's a way to actually extract from a data set you constructed, extract a measure of social desirability sort of across regions or something?
Right. So the method that we've developed basically allows you to estimate the proportion of people who are saying yes to socially, sensitive question as a function of your characteristics. So you can say, if you give me somebody's characteristics, I can give a predictive probability of that person answering yes to the sensitive question. So what that means is that you can then compare that with the actual answer to see whether there is a discrepancy. So you can actually get the estimate of social desirability bias as a function of respondent characteristics. We've done this in the Mississippi example, and we actually didn't find like a very strong evidence that the particular type of the people seems to be lying. But it could be just we needed more statistical power to get that. We looked at like education, age, and gender and things like that. But it seems to be from our analysis, like everyone is across the board lying. And you can kind of see that by looking at the county level results. So if you look at direct question, I mean, with the exception of this Hancock County, which I don't know what's going on there, but you can see the bias is, roughly the same across these very different counties.
I was thinking it might be across issues. So some issues.
Oh, across issues. Yeah. Oh, that's interesting. Yeah. No, certainly that would be interesting. Yeah, in the political analysis paper, we done some analysis of like, although it's the same issue, but affirmative action and like other types of racial discrimination issues. But yeah, certainly you can calculate for each issue area. You can characterize who is giving a more biased answer than others.
Well, we've got some email questions, so I'd like to get to those. So
Sure.
this comes from Scott Gelbach, professor at University of Wisconsin-Madison.
Hi, Scott.
He says, yeah, thanks for talking indirectly here.
Right, exactly.
Thanks very much for this webinar. I was hoping you could talk a little bit about implementation practices that can reduce bias with indirect survey techniques. Shuchiya and Hirai 2010 suggest that bias with list experiments can be reduced by asking for both the number of applicable and non-applicable items rather than just the number of applicable items. And Scott asks, what tricks of the trade you can suggest along these lines?
Right. So I think there are two practical recommendations I would make. So the designs that I introduced today is a very basic design, and it's perhaps not very optimal design. So there are other designs within each of these survey experiments that gives a lot more protection, privacy protection to respondents. So in the list experiment, for example, there's a thing called double list experiment that gives more privacy protection and actually higher statistical power. The randomized response method also has a large number of different designs, some of which gives a lot higher privacy protection. So one of my co-authors, for example, Graham Blair, did this in Nigeria, where he was asking the support for militancy, and here he basically asked people to flip a dice, and basically asked, if you get one, and you don't tell the outcome of the dice flip to the enumerator as a respondent. If you get one, you say yes. If you get six, you say no. And anywhere between, you actually answer the question. So that way, it's like there's a complete protection. Mm-hmm. So I would encourage you to look in some of my papers and the literature to see, depending on the situation, depending on the country, the setting, some designs are feasible, other designs are not feasible. Like in Afghanistan, we couldn't use dice because the flipping the dice is seen as a gamble, and it's against the Islamic law and the Taliban controlled area. They really don't want us to be doing that. And so there's a feasibility issue, but there are variety of options out there, and many of which we've reviewed in our paper and developed some methods. Now the second and perhaps most important recommendation is to do pilot, practice with the actual population that you are dealing with. So we've, for the Afghanistan survey, we've done twice or perhaps even three times the pilot with 20, 40 people, locals that are actually the typical respondents you might get. And we found out because that population is completely illiterate, we couldn't, in the list experiment, we have to read it out. We can't actually show what's written because, they're illiterate. And a lot of people had a hard time if you had an item of 5 of them. They ask you to repeat many times. And then randomized response coin flip. Over the phone we did the practice round, and that seems to have helped. And even in the list experiment, I didn't mention, in Afghanistan we had a practice round. How many of the following do you like apple and oranges, and and then you ask what about Taliban? And so practice round is important with the actual respondents, but also the piloting, the endorsement experiment, piloting is key. You want to think about what are the questions that works and that are what are the questions don't work. So there are a lot of things that's going behind the scenes that make these, methods successful. And so I think like any good research, you have to put a lot of energy and time into it to design before you roll out the full study.
All right, we have another question from Yusuf Shahud. Yusuf asks, I wonder what Kosuke's thoughts are on the use of manipulation checks in these designs. for example, to improve precision. That is, the subtle interventions can be somewhat of a double-edged sword. On the one hand, shielding the respondent, but on the other hand, raising the question of whether the respondent received the treatment.
Right, right, yeah. So that's a very good question. I haven't done much work on that, and somebody I think should do it, right? So the question is, like, suppose you get the estimates that are not very informative, right? But does that mean there's no support, right? Or there is support? And you know, it's hard. It's hard to know whether your questioning technique is not working, or it's just that actually there's nobody who is supporting for certain actors or doing certain sensitive behavior. So I think about manipulation checks, if you can incorporate it into a survey analysis without sort of having causing a problem in some respondents, I think that would be very, very desirable. And that's another way to see if there is if your question is working. Now there is another. This is again double-edged sword, I think, because if your intervention is too strong, then the respondent will notice it, and they will react in a way that you probably don't want to be reacted against. So like an endorsement experiment in our case is very subtle because there's only one word that's different, and people are only assigned to one condition, and you're asking, so as if asking the questions about policy as opposed to the actor. Whereas the risk experiment is still very sensitive in that you're asking like the actor's self still, and people are very skeptical about that. In fact, it turns out that when we did the risk experiment with Taliban being a sensitive item, nobody said 0 in the treatment group, and nobody said 4.
Mm-hmm.
So what that means, this population whose median years of education is actually 0, right? So most people haven't gone to school ever. They are acting very strategically. So they are saying, I don't want to answer this question, so I'm going to give an answer that you cannot tell me. You cannot tell whether I'm actually supportive of Taliban or not supportive of them. So, to me, that's incredible. That the intervention in that case was too strong, and leading to the reaction that basically people are still trying to hide, and they know exactly how to do that. That is not to say 0 or not to say 4, because if you say those two things, you reveal your answer. So again, I think this is a very important point. You want to make sure that the intervention is working, but in some sense, if it works too strongly, then you lose the whole point. And so it's a difficult issue.
I want to follow up on that by asking about. So it seems like in principle, if you ask enough questions, you can start to get a very good idea. You can identify individual responses.
Right.
And that raises a couple of questions.
Right.
I mean, some of them are just practical, like, what do you tell your IRB? Do you tell them that you're going to be able to figure it out or not? Right. And secondly, when you go to promise somebody who's in the field, these are the questions that they're going to remain anonymous, whatever. To what extent, yeah, maybe any one question you couldn't recover the answer, but from all of them you could.
Right. Yeah. So from scientific point of view, you don't want to say ahead of time to the respondents that this, some of these techniques would not pin down the answer by designs, although you can get the high probability. So, so that I think the question is probabilistic protection, even if it's like 90% of chance you said yes, is it sufficient protection for this population, or is it not? And so far we've been able to do these experiments without saying how this experiment works directly to the respondents. However, depending on the design you use, sometimes telling them that actually this protects your anonymity, if it actually does, informing them before they answer is actually important because, like any of us who teaches randomization in the intro statistics courses, it's not necessarily the easiest concept to understand. So a priori, people may not be aware that this actually protects the anonymity. So in some cases, you might want to say that, by the way, we're asking this way because from the response you will give, whatever it might be, we will not be able to identify your actual response. And so, that could be helpful in some population where there's, remain skeptical of what the privacy protection. So I guess you have to work with IRB to, decide what level of protection is sufficient and what level of information should be given to respondents. Again, this is, I think, case by case, and you want to be careful, given the subjects that and topics that you were studying.
Okay, well, we're about out of time, so first I'd like to thank Kosuke for his presentation this week. Thank you very much. I'm sure all the audience and I definitely appreciated it. Next week, at noon Eastern, 11 Central, we'll have a presentation by Matt Lebo of Stony Brook University. He'll be speaking about joint work with Chris Weber, and the talk is entitled An Effective Approach to the Repeated Cross-Sectional Design. So you can tune in next week to check that out, and you can visit our website, which I'm flashing up here right now, methods-colloquium.com, to get more information about next week's talk. I'll have a video from this week's talk posted there for your viewing enjoyment, and slides and materials from this week's talk, and also information about next week's talk will be available there as well. So, Kosuke, thank you very much.
Yeah, and let me thank Justin for organizing this. I think this is a great way of, having a forum that otherwise wouldn't happen. I think the talks that often only convey to local institution can be reached by the global audience, and so I think it's a great idea, and I thank you for putting all the efforts and time into doing this, and I've been inviting me for this. Thanks. Thank you very much.
You're quite welcome. I think it went great, and I hope next week goes equally great. So to everyone, thanks very much. Check out our website. Oh, and if you'd like to present, you can visit our website as well. You can sign up to present later this year or next academic year. All right. Well, thanks, Kosuke, and see you guys next week.
Thank you.